So we already did a video on the first page of the practice midterm. This is the second page, and we're doing the odd ones only. These are way more questions than what are on the actual midterm itself. So if you just study the odd ones, you should have enough knowledge to get a good grade on the actual midterm. But of course, I recommend you practice all of them, odds and even ones. So number 15, we're going to simplify this radical. And we need to go back to the basic rule of radicals. The square root of a times b, it could be broken up to the square root of a times the square root of b. So we need to remember that. So whenever we have some items that are being multiplied, like right here we have the 5,041 times a to the 13th times b to the 22nd. We could technically split that root to each one of those. I'm sorry, I forgot the 1 right there. 5,041. So the square root of 5,041, 71. Perfect, thank you. So 71, no more square root. The square root is the nice number 71. Now, the square root of a to the 13th, we need to remember also that a square root is really the power of 1/2, which is really kind of like dividing the exponent by 2. So we would like to have a value that's divisible by 2 when you have a square root and something to a certain power. You want that power to be divisible by 2. So you might want to rewrite a to the 13th as a times a to the 12th. Because after all, a times a to the 12th is a to the 13th. And if you were to split this square root to the a and to the a to the 12th, you would have, let me actually show my work over here on the side. The square root of a times the square root of a to the 12th, you will get, this becomes a to the 6th, and the square root of a is going to stay the square root of a. So this middle term right here, it's going to be rewritten as a to the 6th times the square root of a. So we really have 71 times a to the 6th times the square root of a. And like we said, this last one, the power, you want it to be divisible by 2. It is divisible by 2 because the square root is the power of 1/2. And 1/2 of 22 is 11. So we end up with b to the 11th. No more square root. So that's our answer. We just need to put it in order. Everything that's outside of a square root, we put it in front of whatever is inside of the square root. So the final answer is 71, a to the 6th, b to the 11th, and then the square root of a all by itself at the very end. There's your answer. Moving on to question 17. So number 17 is probably the easiest one if you have a Casio calculator. All you do is type it in exactly the way it is into the Casio calculator, and it'll simplify and give you your final answer of 5 square root of 13 plus 2 square root of 10. Again, to be able to do this, you need to know where to type in your square root values. Right there, that's the square root button. And just make sure you type in each individually. In other words, when you hit that square root button and then hit 160, then you have to hit this arrow to get outside of your square root. And then you could hit the plus sign because then it'll be outside. But you have to hit that right arrow to get outside of your square root. So hit this right arrow to get outside of your square root. I hope that helps. There's really no math to do. If the calculator does it for you, that's your answer for number 17. Moving on to number 19. Again, we're doing the odd ones only. It says change the radical to a rational exponent. Remember, a rational exponent is an exponent that is a fraction. And I hope we remember that a rational exponent, see, when we talk about any root of any value in here to whatever power, it really becomes whatever that value was with the power over root. So we need to remember P over R, power over root. So this really does become x to the power over root, 3/4. And it's an exponent. It's not x times 3/4. It's x to the 3/4 power. That's number 19. Let's go to 21. This one says chand. I messed up. Should say change. Sorry about that. Change the rational exponent to a radical. Well, what kind of root do we have? What is the root on that rational exponent? Come on, guys. Power over root. Power over root. The root is 5. So we're talking about the 5th root, right? How about this? When you have a power to a power, what do? You multiply these guys. So if you go 13 times 17 on a calculator, you get 221. So what we really have here is x to the 221 over 5. So what does that mean? That it's going to be the fifth root of x to the power of 221. So that's your final rational exponent changed to a radical. The fifth root of x to the 221. Moving on to number 23. Again, I recommend you do all of them, but on this video I'm explaining the odd ones only. And if you do, just stick with the odds. You should have enough knowledge to do well on the midterm. Number 23, we do have a square root inequality, and we need to remember that whatever is inside this square root, we need it to be at least 0, right? The square root of 0 is 0. The square root of anything greater than 0 you could actually do. But if you end up with a negative in here, the square root of negative 4, the square root of negative 1, that produces an imaginary value, so that would mess it up. So let's begin with that restriction that your radicand value, the 2a minus 3, has to be greater than or equal to 0. Let's begin with that. So when we go add 3 to solve for a, we're going to end up with 2a is greater than 3, which means if we divide by 2 on both of them, we'll get the final answer, a is greater than 3/2. Or you could also say a is greater than 1.5. I'm just going to leave it 3/2, even though we know that that means 1.5. So what else? Now let's go back and solve the entire inequality. If I want to get rid of a square root, I'd have to do the opposite of a square root, which is actually squaring. Right? The square root squared, the square and the square root, they're inverse operations. They will undo themselves. So if you did do that, you would end up with 2a minus 3 is less than, but then again, if you squared the left side, you have to square the right side, which would mean you get 25 on the right side. 5 squared is 25. So this is your new inequality that you're solving. Let's get rid of the minus 3 by adding 3 to both sides. We end up with 2a being less than 28. If we divide both sides by 2, we're not dividing by a negative, so you don't have to flip the inequality symbol, it stays. A is less than 14. So let's think about the two answers. A is greater than 1.5 or 3/2, and a is less than 14. So we need to think about a number line to determine whether we write these answers together as a compound inequality or apart with the word or maybe they overlap in one direction and you only have one of them as an answer. So what we have here is 3/2, which is 1.5. We have 14 over here. And on this first one it says a is greater than 1.5. Greater than is to the right. I'm sorry, that one should be greater than or equal to, because this thing had to be greater than or equal to 0, so it should still be or equal to. And this one says a is less than 14. Less than 14 is this way. As you can see, it's an area that's together between these two values. So your answer would technically be the x being right in between those two values with less than symbols, but this one's an or equal to. So there's your compound inequality answer for that problem. That's number 23. Let's jump to number 25. Right here we have a rational exponent. It's technically a third root, but we don't even have to change it to a third root. We could just work with this, subtract 2 on both sides to start getting the x by itself on the left side. Let me rewrite what I have. Parentheses 7x minus 20 to the power of 1/3 equals -5. Now to get rid of the power of 1/3, you could take the whole entire left side and raise it, or not raise it, but put the power of 3 on it. That way you have a power to a power which you'd multiply, and 1/3 times 3 is 1. It would eliminate. You have 7x minus 20, no more power of anything. Power of 1 technically. But of course what you do to one side you must do to the other side, so power of 3 on the -5 as well. So we did say that a power to a power you multiply. 1/3 times 3 is 1, so what we have is 7x minus 20 to the 1 power, which is unnecessary to put to the 1 power, equals, Negative 5 times negative 5 is positive 25 times negative 5 takes you back to negative 125. So we're almost done with this. Let's continue to solve. We're going to go plus 20. Plus 20. We'll end up with 7x equals 105. Negative 105, that is. And let's divide both sides by 7. 105 divided by 7 on a calculator is 15. So we have here x equals negative 15. Thank you. So that is the answer to number 25. X equals negative 15. Let's continue on to 27. Right here we have the fourth root. Let's continue solving here. So let's get rid of that plus 3 by subtracting 3. Subtracting 3. You will have 9 parenthesis 4u plus 1 to the 1/4 power equals 27. We need to get rid of that multiplication of 9 in front of the binomial. Let's divide by 9. Divide by 9. You will get 4u plus 1 to the 1/4 power equals 3. You want to get rid of the 1/4 power? What are you going to do to both sides? Put what power? 4. 4. And of course, power to a power, you multiply. 1/4 times 4 is 1. So you'll just get 4u plus 1. I mean, imagine, I could put to the power of 1, but that's totally pointless. So I'm not going to do that. I'm just going to leave it 4u plus 1 equals 3 to the 4th. 3 to the 4th power on a calculator is 81, if you didn't know. And let's continue solving. We are going to subtract 1. Subtract 1. We will have 4u equals 80, which means if you divide both sides by 4, u equals 20. So that is your answer for number 27. Let's jump to 29. Again, practice doing all of them, but at the very least, do the odd ones, because the odd ones practically gives you a taste of everything that you're going to see on the midterm. Number 29, we want to solve. We're going to use a calculator. We need to have the knowledge that to get rid of an exponent situation, we're going to apply a logarithm. But before that, well, here's x. I need to get rid of everything except for x, so it's really easy to get rid of that 1. So let's get rid of that plus 1 by subtracting 1. Let me rewrite it. I have 5e to the x power is greater than or equal to 6. I would now get rid of the 5 that's in front of the e to the x by dividing by 5, since I really was multiplying by 5. So I divide by 5, that'll cancel out. What you do to one side, do to the other. What we have now is e to the x is greater than or equal to 6 over 5. Now, I need to bring down this x. I do not want this base e. X is an exponent, and to undo an exponent, I use a logarithm. What kind of log am I going to apply? Log base what? Log base e, which is ln. So I could write log base e of e, but we know that the correct notation for log base e is simply writing ln. ln of e will cancel it out. ln of the fraction 6 over 5, I don't know, that's what we're going to do on the calculator. So your answer will be, you see these guys canceled out, the x came down, it's greater than or equal to, and if you actually type in ln of the fraction 6 divided by 5 on a calculator, you will get, sorry, it took me a while, 0.1823, because the next number is a 2, which won't change the 3. So this is your final answer for number 29. Let's move on to 31. How do I bring down that 3x from an exponent to become a regular 3x? How do I get rid of this base e? By applying what? Log base e, which is really ln. And what you do to one side, you do to the other side. So ln of e eliminates. 3x comes down. ln of 8, that's a decimal number, an irrational value. So we're going to get rid of the multiplication of 3 by dividing by 3, and the rest is done with the calculator. X equals, so we have, let me actually show you on the calculator. There it is. Type it in directly like that. ln of 8, the ln button's right here. Type in 8, close parenthesis, and then put it over that 3. Begin with the fraction button, obviously. But that's your answer right there. The answer is 0.6931 because the 4 will not change that 1. It'll stay the same. So your answer is x equals 0.693. Moving on to question 33. Wait, it's not on this side. You know what? Let's do 32 just for funsies here. And then we'll wrap up this video. We'll do a different video for the third and final page. So how do I bring down that 2r? What do I have to apply? Log base what? 7. Log base 7. And we do to one side, do to the other, log base 7. So log base 7 of 7, that eliminates. You have 2r equals log base 7 of 26. So we almost have r by itself. All you need to do is get rid of that multiplication of 2 by dividing the whole thing by 2. And once again, the calculator gives you your answer. The trick is to begin with the fraction button, and then up on top, in the numerator position, type in this special log button, log base blank of blank, and then plug in the base 7 of 26, and down here put the 2, hit equals. This will be your answer. You have to round to 4 decimal places, 1, 2, 3, 4, but the 6 does convert the 1 to become a 2, so your final answer will be 0.8371, actually 372, not 1. So that would be your answer right there. R equals 0.8372. So I hope that makes sense. And we will do a third video explaining the final page of the practice midterm. The odd ones, that is. You know, let me go back to 22 and 24. These are good problems to do. These were back when we were doing radical inequalities. In order to solve a radical inequality, you want to first start with the truth that whatever's inside the square root has to be greater than or equal to 0. You could have the square root of 0. You could have anything that's greater than 0. So anything 0 or greater than 0. So I would begin by stating that my z plus 5 has to be greater than or equal to 0. Okay? If it's not greater than or equal to 0, that would mean that it's negative, which means it would be imaginary. That would mess this whole thing up. You only do this on inequalities, right? If it were an equation, you would just solve it, get it by itself, and apply a power of 2 to get rid of the square root. But if it's an inequality, you take whatever's in here and state that it has to be greater than or equal to 0. And then you solve it, and that's one possible answer. So minus 5, we have z equals, or no, is greater than or equal to negative 5. And that's your answer. Z is greater than or equal to negative 5. That's one possible answer. Now let's go back to the whole thing and solve the whole thing. We're going to subtract 4. We will have the square root of z plus 5 is less than or equal to 9. To get rid of a square root, we would square it. We do to one side, do to the other side. You will have z plus 5 is less than or equal to 81. Then we get rid of that 5 by subtracting 5. Final answer, final possible answer is z is less than or equal to 76. So we need to think about both of these inequalities on a number line and see if they point together or they're apart. If they're apart, it would be a no solution because you want to represent the overlap piece. In this case, we have z is greater than or equal to negative 5. Here's negative 5, greater than or equal to is to the right. 76 is going to be way over here in the positives. Less than or equal to is to the left. So this area is obviously in between these two values. So our answer will be in between those two values. So we're going to simply put the x right in between those two values with the less than symbols. So this is your answer, the compound inequality for that problem. Let me do one more. This one right here, you're going to begin by saying that this inside value cannot be anything that's below 0. So you're going to say that 2a minus 3 has to be greater than or equal to 0. So if you solve it correctly, you'll get a is greater than or equal to, you know what, let me show my work instead of just giving you the answer. I'm sorry, here you go, plus 3, 2a is greater than or equal to 3, divide by 2, a will be greater than or equal to 3 halves, which is about 1.5. That's a possible answer. The other answer comes from squaring both sides of this inequality, and you will have 2a minus 3 is less than 25. And then when you add 3 to both sides, you'll get 2a is less than 28. Divide by 2 on both sides to get a is less than 14. So again, you need to check and see if this is an area that's together or apart or going in the same direction. You want to represent the overlap piece. So right here you'd have 14 on this side, 3 halves on this side. This one says that it's greater than 3 halves. This one says that it's less than 14. So again, it's an area together. Put the x in the middle, put the less than symbols, and you're good to go. That's your compound inequality answer right there. So on this video, I pretty much covered almost all of them. For sure, all the odd ones of the second page.